Hi everybody, this is Dr. Bitla Venu. I would like to discuss the topic of CAD softwares used and available in the commercially available in the market. In the last class, we have seen the CAD workstation hardware components used in CAD system, in which you have the different types of input devices we had seen in the last class. Like input devices are like what are those, like graphical terminal. We have seen cathode ray tube, then we have seen hard copy devices. We have also seen finally storage devices in the last session. Let me move forward to discuss the softwares commercially available in the market. We will see the glimpse of the different types of softwares available in the market. We will also see the vendors uh, along with the software features. Finally, we will see the different communication networks used in the CAD system. This is the brief objective of this slideshow. First, there are different types of CAD models available that we can create using the CAD software. It may be a 2D CAD, two-dimensional CAD. It may be a 3D wireframe, maybe a surface model, maybe a solid model or 3D CAD modeling. We will try to see, we will try to explore these types in detail in the coming slides. So CAD model is basically a digital file of a real-time object created by a software, CAD software. The moment you create a CAD model using a software, CAD software, that can be converted as a file, digital file, which consists all the data related to that CAD model. That means that a digital file or CAD file is going to carry all the related information or all the information related to the model. The information may be boundary representation data, which consists the vertices, lines, planar area, planar information, then boundary information, all will be gathered in that file. CAD model is a digital file which is going to store all the data. That data is a boundary representation data stored in that file, created by using any of the CAD software. Let me move forward to discuss these CAD models. The first one is a 2D CAD model. A 2D CAD model is a geometric model of an object which is created in a two-dimensional plane or a Cartesian plane. That means in two-dimensional plane only, these CAD models are created. Third dimension will not be given. Means in the Cartesian plane, 2D model is created, or object is created. So that type of 2D CAD model you can see in this figure. It is represented, the x and x-axis dimensions and y-axis dimension is represented in this figure. The third dimension will not be represented. So these 2D CAD models are having some advantages and disadvantages. These 2D CAD models are used for representing the cutouts, paper cutouts, and for the sheet metals, simple objects. These are very much flexible in drawing, but whenever we want to represent the data or the entire information of the component, these 2D CAD models are not useful. So let me move to the other types of CAD models. 3D wireframe model. So this type of model is going to describe an object with the boundaries or the edges I mean, this object is going to describe an object using the boundary edges. The edges may be the lines or the arcs. When you create a wireframe model, that wireframe model consists only the edges. That means the model is described by the edges only. Just like a skeleton that you can observe here in this figure. This figure consists only the edges and the arcs. Lines and arcs you can observe here. So that means the model which is described by using only the edges is called the wireframe model. Of course, it is a three-dimensional figure, but it is just like a skeleton. It gives you some visualization, some clear visualization than the 2D model. It is just like a skeleton. It is having only the edges, maybe the lines or the arcs. This 3D wireframe model consists the lines and arcs. In turn, those are called the edges. Then you have the other 3D CAD model. It is a surface model. Surface model is also a 3D CAD model. This type of modeling, this type of surface model describes an object using the surfaces, boundary surfaces. That means this object consists only the surfaces. You can, if you see that model, you can see only the surfaces. That type of surface model you can observe in this figure. This figure consists only the surfaces. This surface model gives some clear visualization, clear realistic visualization, or the realistic, it looks like a realistic model when you compare with the wireframe model. Of course, this may not be a right technique, but to some extent it is a good technique. When you compare with the wireframe model, it gives us some picture or to visualize the model. Once again, I would like to define this surface model is going to describe an object using the boundary surfaces. It is a realistic design. It looks like a realistic design. It may be a right technique to create the model. It gives some clear picture than the wireframe model. This is what you can observe in this figure. Let me move forward to see this solid model or a 3D CAD model. This model is going to describe a solid and considered to be the most useful CAD model for the downstream applications such as design and manufacturing. This appears to be same as the surface model. This 3D CAD model appears same as the surface model, but it is having the properties. You can assign the properties like weight, volume, and the density. That means the additional properties means the physical properties that you can assign to this solid model. When you compare with the surface model, you can assign the physical properties to the solid model. Whereas in the case of surface model, you cannot assign the physical properties in the case of surface model. It gives us a very clear picture, and this model is used in the downstream applications such as design and manufacturing. After creating this model, this solid model, you can send this model for the analysis also. In the case of design, you can analyze that for the safety, and you can calculate the different stresses, failure stresses. In the case of analysis, you can send this product directly to the manufacturing also. The moment you complete the analysis, you can send this model to the manufacturing for the coding based on the features that object is having. This is the real-time object. Normally, this type of object is used in the downstream applications of design and manufacturing. When you come to the different types of CAD software, CAD software, different CAD softwares are available in the market. CAD software is basically composed with the or the collection of the different programs. Different programs are combined together, are collected together to do some specific task. In this case, so for example, you take one application. The function of the application is to perform some function. Similarly, in this case, CAD is also having the number of programs in backend. This CAD software, all the CAD softwares are having the number of programs which are collected together to perform one function. That function is drawing here. That function is to create the models, solid models in this case. So CAD software is also termed as a graphics software. The functionality of the software is to create the graphics, maybe 2D model, maybe surface model, maybe a solid model. The function of the CAD model is to create the graphics or the models. This CAD software, as I said just now, is the collection of the number of programs to perform one specific function. That function in this case is to create the models, solid models. Then there are different functions. The CAD softwares used in any of the case is to increase the productivity of the designer. It must have some features. The CAD software must have some features. Whenever you want to use any CAD software, it must have the following or these qualities. CAD software increases the productivity of the designer. The productivity means, in this case, a designer can design number of components than when we compare with the manual designing. Assume that a designer can design a component in 1 week. When we use this graphic software, designer can design or create 2 to 3 components in 1 week based on the performance of the designer. Hence, the productivity of the designer increases in this case. Here, the productivity concept is that the designer is going to perform more designs in a day or in a week or in the specified target time. Then the designer software must have all these qualities. It must be able to improve the quality of the design. The CAD software, when you use the CAD software, it improves the quality of the design. It also improves the communication through the documentation. That means it must have capability to form the documentation. So the moment you create a design, the moment you create a model, you can get the documents from the software. That is what he is trying to say. To create the database for the manufacturing, this software, the CAD softwares are also going to create the database, which consists the information related to the manufacturing. This CAD software is going to create some database, or it is having some information that can be used in the manufacturing side. So these are all the some qualities of the some features of the CAD software when you want to use. So that software must have these qualities or these functions that should be able to perform these functions. There are different types of CAD softwares available in the market from the different vendors. The AutoCAD software is famous one. When you go outside, almost all the mechanical domain people aware about the AutoCAD. AutoCAD means basically this AutoCAD software is used to create the two-dimensional drawings. It is famous to create the two-dimensional drawings, but it is by using this software, it is somewhat difficult to create the 3D modeling. This is the major disadvantage of the AutoCAD. AutoCAD is more flexible to create 2D drawings. This AutoCAD is from the Autodesk, which was released in the market in 1982. It is established CAD software across the industries in 1982, but it is obsoleted now. CAD software, of course, some extent for the 2D drawings you can use this AutoCAD, but whenever you want to create the advanced surfaces, non-planar advanced surfaces like the B-spline, then non-planar toroidal surfaces, then spherical surfaces, non-planar surfaces. So it is difficult to create those type of surfaces using this AutoCAD software. So that this AutoCAD software is obsoleted nowadays. So as I said just now, this AutoCAD is obsoleted. It is not that much easy to create the 3D modelings. That's why it is obsoleted. Then you have the ThinkerCAD and FreeCAD. These two are also softwares. Uh, these are these two softwares are used to create the 3D drawings or the 3D models. Some extent, ThinkerCAD is from the Autodesk. This AutoCAD is also from the Autodesk company, commercial company. They will create the software. They will sell outside Autodesk. ThinkerCAD is from the Autodesk. It is coming from the Autodesk. This ThinkerCAD, by using this ThinkerCAD, you can create some basic 3D modeling. This ThinkerCAD is having a library. In that library, you have some basic primitives like cylinder, sphere, 3D primitives, cylinder, sphere. Then you have other regular shapes. So from that library, you are going to pick up whatever the shape you want and drop on the screen wherever you want. And you are going to perform some operations on that. Suppose if you want to make a hole in a cylinder, so in that case, you are going to perform operations subtracting one more cylinder, one more cylindrical hole on a cylinder, you will create a hollow cylinder. This is what some rules are defined in ThinkerCAD. Some basic operations will be performed to create the 3D model in the case of ThinkerCAD as well as the FreeCAD. So this ThinkerCAD and FreeCAD is used to create basic 3D modelings. So not for the advanced 3D modelings. It is these two softwares are having library, 3D library, in which you have the different 3D primitives, means shapes. So from which you can pick up the shape whatever you want, and you can drop on a model or a rough object. So that creates a shape on that on the rough object. Then when you move forward, even ThinkerCAD, FreeCAD, AutoCAD are not flexible to create the complex shapes. So the PTC Creo is one of the software, one of the market leader in product design. This was developed by Parametric Technology Corporation. It is a PTC. This is 30 years back. This PTC developed Creo, PTC Creo, and Pro is also from the PTC. This is also a modeling software. 3D modeling softwares are more flexible to create. Solid modeling softwares are more flexible to create any type of shape or complex shapes. So PTC Creo, Pro E, the previous version of the PTC Creo is a Pro Engineer, Pro E. That is also more flexible. So the advanced version of that PTC Pro Engineer, Pro E, is Creo. Creo is one of the market leader in the product design. And almost this Creo PTC is going to capture maximum share in the globe. Most of the designers prefer to use PTC Creo. Of course, there are other 3D modeling softwares. Of course, those are also used in the market. But this PTC Creo is having more experience and more, I mean, this company is having a leader in the market. So most of the people will prefer to use PTC Creo. This was developed 30 years ago. Now you can imagine up to what extent they are leaders in the market. Then when you move forward, it integrates many functionalities such as thermal, structural, motion, then parametric and freestyle surface generation. Using this PTC Creo, you can create freestyle surface generation, freestyle. So in what way you want, you can create using this software. Using this software, you can also thermal functionalities integrate. I mean, this software can be integrated to the thermal, structural, and the motion, then parametric and freestyle surface generation. So this is very powerful tool which is commercially available in the market from the Creo or from the PTC. The PTC is the company and Creo is the version. This is the advanced version to the Pro Engineer. Then these are all the functionalities. Thermal functionality, it is having structural functionality, then it is having parametric and freestyle surface generation. This feature is having this is very good software, and it is ruling the world, ruling the globe in the case of 3D modeling. So it is a complete tool. Basically, this is a complete tool ideal for additive manufacturing. Additive manufacturing means 3D models are created, or the 3D models are created from the 3D model. I mean, the objects are created from the 3D model. Whenever you create an object using a 3D CAD model is called additive manufacturing. Additive manufacturing is also can be termed as a 3D model. Sorry, a 3D printing. 3D printing and additive manufacturing almost similar. In both the cases, the components or objects are manufactured from the CAD model. It allows to perform all the dimensioning calculations. This software will also allows us to perform all the calculations while modeling the final idea or while finalizing the design, so that it is more flexible to alter the dimensions. It is more flexible. Suppose you are created one dimension, suppose you are created one component, but the modifications are flexible in this case. That's what he is trying to say. Then you have the other software, commercially available software in the market, that is Fusion 360. This is developed by Autodesk. This Fusion 360 is a cloud-based 3D CAD program. Cloud-based means somewhere you have a software, you are keeping some software somewhere else remotely, and that software is used by number of users. So that this is called the cloud-based Fusion, a cloud-based application program. So this Fusion 360 is cloud-based, means cloud-based 3D CAD program means this is developed, you can keep somewhere, this program can be kept somewhere in a remote system, so that can be used by the number of users. So that is called the cloud-based program. So this is also very flexible. Instead of purchasing number of licenses, you can make one system as a client and you can use that software by the number of users. So this is the flexibility of the cloud-based 3D program. So this is also a famous software commercially available in the market. This is developed by the Autodesk. The first software developed, AutoCAD, is developed by Autodesk only. So this is a famous 3D modeling software. Software. The advantages of this Fusion 360 platform is that it stores the entire history of the model. Suppose you are created a model, 3D model, so you are doing so many modifications on that. So that modification history will be available in this software. Whereas in the case of other softwares, the modification history is not available. That is also one of the greater flexibility in the case of Fusion 360. Example, you take the other softwares like ThinkerCAD, FreeCAD, you perform any modification on the solid model, that history is not available. But whereas in the case of PTC Creo and Fusion 360, the modification history is available, so that you can go back and you can see what are the operations you are performed on the 3D model. So this is a very good flexibility in the modeling, 3D modeling software. This software consists the number of options, like including freeform, solid, and mesh modeling is also flexible. Can also be performed mesh modeling, freeform, and solid modeling is also possible in this case. Then when you come to the SolidWorks, so this SolidWorks is from the Dassault systems, published by the Dassault systems. It is often used by the professional 3D designers. Of course, this Creo as well as this Fusion 360 is also used by the professionals. Of course, this SolidWorks is also used by the professionals, 3D professional designers. This is published by the Dassault systems. It is a parametric feature-based model. The software includes a wide range of features such as design, validation tools, or maybe reverse engineering. Parametric feature-based model means you have some library. In that case, some specific rules are there. Like to create one model, there are some specific rules. So those rules are adopted to create the model. So that is called parametric feature-based model. Some specific rules are defined. You have a library in which from the library you can pick up all those primitives or the basic models, and predefined rules are used to create the model, solid model, as per the requirement of the client or the user. One of the special feature is that unlike other softwares, it is going to create the structure in the form of nerves. Nerves means it is going to convert all the surfaces, lines into the mathematical model, like B-spline curves and B-spline surfaces. Nerves are closely related to the mathematical models. It converts the surfaces into the planes and edges. All these will be converted into the mathematical models. One of the disadvantage of this SolidWorks is that users of the software is limited ability to import STL files. Of course, this STL is a neutral format file. By using SolidWorks, you cannot create a STL file. That is a major disadvantage of this SolidWorks. Of course, you can create, but it is going to lose some data. That is the disadvantage of this SolidWorks. If you create an STL file is used in 3D printing and additive manufacturing. That file is directly connected to the 3D machines to create the 3D models. So that this is one of the disadvantage of the SolidWorks. So you try to remember this. This is the disadvantage of the SolidWorks. This is basically developed by the Dassault systems, and it is used by the 3D professionals. Then CATIA CAD solution historically developed for the Dassault aviations for their own needs. This SolidWorks as well as this CATIA is developed by the same company, but this CATIA is developed for their own needs. It is powered by the 3D experience platform. That means the visualization, the alteration is very flexible in CATIA software when you compare with the SolidWorks. The owners of CATIA as well as the SolidWorks both are same, but the experience when you work in these two is different. This CATIA is having very much flexibility while creating the advanced softwares. Like you take the turbine profile, turbine blade, it is very complex shape. It is very difficult to create. Every coordinate is going to vary. When you integrate this model or while manufacturing, while machining this turbine blade or the impeller blade, the tool coordinate from point to point, all the coordinates will vary. So it is very difficult to manufacture or the machine those impeller surface or the turbine blades or the advanced surfaces. Those advanced surfaces can be created in flexible way using this CATIA software. This CATIA software is developed by the Dassault Aviation for their own needs, so that it is more flexible and it is a 3D experience. It works or it is powered by the 3D experience platform. It is more than a simple CAD software. Yes, it is more than a simple CAD software. when you compare with the other softwares. It is also a multi-platform software. Multi-platform means you can create the model, and some extent you can create some database useful for the manufacturing. You can see here. So this some extent the data can be used for the manufacturing side. The database generated using this software can be used in the manufacturing side also. Then computer aided engineering also, some data is useful. Of course, not all the data is used in the computer aided engineering. Some extent, some data stored in the neutral format file can be used in the analysis side also. This is the advantage of the CAD here. Then OpenCAD is also one 3D modeling software. It is an open source software to create the solid 3D CAD objects. It is having some own descriptive language. As I said just now, this software is also going to create some 3D library in which all the primitives are stored. Primitives means regular shapes which are going to be picked up, or which are going to be used regularly, from which we are going to create the complex model. Like in the library, as you can see, the primitives like the spheres, boxes, cylinders, wedges, all can be stored at one place. Suppose if you want a cylindrical hole, we are going to pick up a cylinder from that, and that will be subtracted from the raw component to create a cylindrical hole. Like that, we are going to create the features on the raw component or the workpiece or an object. It is this OpenCAD is having their own programs and own rules are used to create the 3D models. This is also one of the software, commercially available software in the market. It is a free software application. Of course, it is having the commercial version and as well as the free version. We can purchase also. If you want to use this software commercially, we have to purchase that. Otherwise, the open source or the free source is also available in the website. Then you have a Reno. Reno is a commercially 3D computer graphics. Of course, this is completely a commercial software developed by the Robert McNeil Associates of an American. So privately held employee-owned company. It is in the 1980s. It is also an old software. Of course, with this also you can create the 3D models, but basically this is used to create the advanced surfaces. In this case also, all the surfaces, all the lines, all the data is converted into the mathematical model. So the programs involved, the rules involved in Reno software is also complex, but the accuracy is more in this case, Reno software. When you use the Reno software, if you convert that model, when you use the Reno software to create a model, when you convert that model into the neutral format file, so it is going to carry the accurate data. When you integrate that file to machining, it carries the data of all the information without losing any data. Suppose after converting a solid model, if you create that model, or if you want to import that model into the different vendor software, we need to create a neutral format file. Neutral format file is a file which can be created from the solid model to open in the different vendors. It's a neutral. You can open that software, any commercially available software that is an ISO approved file. You can open that. Step is an ISO approved file. Step is one of the neutral format file that can be used, that can be converted, I mean that can be used anywhere, or that can be opened any commercially available software. Then when you come to the features of the CAD software, it must have, I mean, whenever you want to use a software, that software must be simple. It should be easy to use. Then it must have consistency. That package must be operated consistently without any error. It should not have any error. It should have consistently gives us the accurate output. That is the it must have consistency. It must be a completeness. Sometimes it works well and sometimes it may not work well. So that means it must be complete enough to use. That means this software must have a completeness, means it should work without any errors. Then it also must have, it also must be robust in its nature. So it should be tolerant of some errors. Okay, so it should have robust in its nature means, I mean, suppose if the user do any mistake, assume that user uh, did any mistake, so it must be able to accept that, it must allow us to go back to rectify that error. That is called the robustness. So the software must be robust enough to go back and to modify the error. Then the software must have very good performance point of view. It should be very much be flexible. It should have the performance should be very high, means possibly it gives us output in a short span of time. It should not take much time, like that. Performance may have different parameters, right? It may be with respect to the time, executing time. It may be with respect to the accuracy. It may be with respect to the appearance of the window. All these comes under this performance. The performance of the CAD software must be very good while executing that software. Then it must be economy. It must be economy. The software must be economy. If the software cost is high, we cannot use that software. So that it must be economy, so easily available. I mean, it must be affordable to purchase. Then when you come to the communication networks, uh, let me go back once again. These are the features: simplicity, consistency, completeness. It must be robust enough to go back and rectify the errors. It must be having very good performance with respect to the exhibition time, with respect to the appearance, with respect to the all the factors. Then it must be economical to purchase. It should not be beyond the scope of the affordable price. It must be simple enough to understand. It must give us the consistent results. These are all the features of the CAD software. Then Reno, OpenCAD, CATIA, SolidWorks, Fusion, PTC Creo, AutoCAD, ThinkerCAD, and all these are the different types of CAD softwares, commercially available CAD software outside. Then when you come to the communication networks, so I mean, we as a CAD engineer, the CAD engineer must always interact with the computers, so that the CAD engineer designers must have some idea related to the networking also, so that this syllabus is also included in the curriculum. So computer networks is an infrastructure, so that all the computers that allow us to integrate computers together. Our computer network, uh, when you define this computer network is an infrastructure that allows to integrate or the connect two or more computers to communicate each other. Computer network is an infrastructure that allows us to connect two or more computers called as hosts to communicate each other. That means when you connect the two or more computers together to communicate each other, that is called the computer network. So two or more computers are connected together to communicate is called the computer network. Basically, this is an infrastructure. This network achieves by providing a set of rules for communication. Suppose if two or more computers are connected together, there are some rules to communicate together, because different vendors will come, different languages, they have to come, they have to interact each other. Maybe the communication language may be different, so that there must be some rules, there should be some rules. The rules must be defined. Those rules are called protocols. There should be some rules to interact with each other by the different clients. Those are called the protocols. So when you come to the terminology in the network, communication network, you have network and communication network. A large number of computers are interconnected or when you connect the large number of computers using fiber optic cable or a copper wire or microwave or infrared or through a satellite, that is called a network. When you connect the number of computers using a copper wire or fiber optic cable or a microwave is called the network. This is specifically related to the hardware. When the computers are connected using network cables or maybe some extent satellite is called network. So those computers are called in that network. Then when you come to the computer network, a system consisting of connected nodes, you have a junction. To that junction, number of computers are connected together is called the network. When the computers are connected to a junction or a node is called a computer network. These computers are connected to that network. Then why do you need the networking? Networking is required to share the resources. Resources means you have a high cost printer somewhere else. You have, suppose if you want to use that high cost printer with the different computers located remotely somewhere else, that is called the sharing of resource. You have a resource that in this case the resource is a high cost printer that can be connected by the different clients located or sat somewhere else is called the sharing of resource. So networking is required to share the resources. Resource in this case, as I said just now, you have a printer. Printer is a resource here. That printer can be shared by the different users sitting somewhere else across the globe. This is called the networking. Then this networking is also required for sharing the information. Of course, you have a computer. In that computer you have some information or you have some software. That software can be used by the different users. That software can be shared by the different users. So otherwise you have one computer, in that computer is having some database, some production information. Example, you take the process planning database. Everybody, you have some process planning database computer somewhere else. Everybody can access when you connect some computers in a network. That database, that process planning database can be accessed by the connected systems which are in the network. This is the this networking can be used for sharing the information. This network can also be used for the communication. For example, you have you have some database, you have some central database. That database is having some information. A client means user can directly access that database and update the database. That means he is communicating. The remote user or the computer is going to access the database somewhere else. That means he is communicating. Not only is using, he is communicating with the central database. This is the example is that the remote location, you have a mobile salesman, he can update the data that is located somewhere else. Is that database can be far away from him. So when you come to the applications of the networking, this networking is extremely used to exchange the electronic data. It can also be used for the teleconferencing, like communicating with each other. You might have seen outside, most of the people will communicate together, video conferencing, so that they are communicating. They're communicating the information. They're communicating together. This is one of the application. Of course, it is transferring the data, which are connected in a network. Then you have the cellular telephone. This is also one of the application. Then you have the cable television. Cable television means all the systems in in an area is connected to a cable, right? Somewhere else is transmitting one movie, and that movie we are able to view at our home. So remotely is playing some data, and we are receiving that data to utilize, to view that data. Example, you take one movie, cable cable operator is going to play one movie somewhere else, and we are able to view that movie at our home. So this is also one of the application. The televisions are in that network. We can call all the televisions are in the network. Then reservation of airlines, trains, theaters, and buses. This is also one application. Then automatic teller machine, ATM is also all the ATMs in an area, all the same banks ATMs are connected to a central server. Those are in the network. Okay. Then you have the internet banking is also one of the application of the networking. The bank servers, the bank computers are connected to one server located remotely somewhere else. That is called the internet banking. Suppose if you perform any operation with the internet banking, your database will be updated. That is somewhere else. That is far away from us. These communication networks are different types. So one is local area network, LAN. In brief, you can call it as a LAN. Then metropolitan area network, that is MAN. Then wide area network, in short form, you can call it as WAN. Wireless network. Then you have the inter network. Local area network, LAN, it is also called as LAN and designed for the small physical areas such as an office or group of buildings or a factory. You have a building in which you have 10 to 15 computers. If all those systems are connected with a central system to share the information or to use the resource, maybe a printer, that is called the local area network. Preferably, this type of network is used for the small physical areas such as an office, group of buildings, or a factory. These LANs are used widely. It is easy to design because this LAN type is used widely because it is easy to design. Personal computers and workstations are connected to each other through the LAN. You can see some type of LAN network here. You have bus network here. You have ring network here. These LANs are different topologies. It can be a star type, it can be a ring type based on the connection type. It can be a bus type, it can be a tree type. All these are the local area networks based on the connection between the central server. LAN can be a simple network like connecting two computers, of course, to share the files and network among each other, while it can also be as a complex interacting an entire building. Okay, it can be a simple connection between the two computers, connection between the very few computers. Okay, it can be like that. LAN networks are also widely used to share the resources. As I said just now, printers are located somewhere else, some room, in a premises that can be shared by all the users in the same building or located somewhere else. Then when you come to the characteristics of the LAN, LANs are private networks, not subjected to tariffs. Okay, these are private networks, so it is not charged and it is not regulated by the controls, and it is not controlled by the regulatory authorities. LANs operate at relatively high speeds when you compare with the typical other types of network systems. Okay, we will discuss in detail in the coming slides what are the different types of network. This is the LAN is one type of network we are discussing now. When you compare with the other type of networks, so these are high speeds. These are connected in the closed proximity, so that, and these are very limited in its nature, so that the speed of the LAN is more when you compare with the other types of networks. There are different types of media access control methods in LAN. That is the prominent one. The prominent one is the Ethernet. Ethernet means you have one junction, and at that junction you can directly connect if you want. That is one type of media connection control, media access control. Then it connects the computers in a single building or a block or campus. As I said just now, we already discussed this, in a restricted geographical area. It may be a building, it may be any closed proximity, or in a single room. You can connect very few computers into a central computer to access the information or to access the resource, maybe a printer. maybe to communicate to each other, right? Okay, that in that way, this is also one of the characteristic of the LAN. When you come to the applications of the LAN, one of the application is that printers you can use, as I said just now, resources you can, and you don't require the internet access. You can share the information, you can access the resource, right? You can share the resource, you can share the information, you can communicate. These three are very, very important characteristics of the LAN. Okay, the clients can access the server. So users, clients here, the clients means users, can access the information, stored somewhere else on a central computer. That means it is a host. This is the these are the applications of the LAN. In the coming class, we will see the different networking systems. In the next class or the next session, we will see the different metropolitan area network, wide area network, then internet access, internet network. We will see. With this, I will close the session. Thank you, one and all. We will meet in the next session related to the networks. Thank you. Thank you, one and all.